In this video, I will show you how to do matrix multiplication in combination with other operations like addition, subtraction, and regular scalar multiplication. So in a problem like number 16, of course, because of the parentheses, the first thing you want to do is add the two matrices. So we add by adding the corresponding elements. So -5 and 5 will make 0. And then 6 and 5 is 11. -6 and -5 is -11. 2 and 0 is 2. 1 plus 2 is 3. 0 plus 6 is 6. Alright, so this is what you get from the addition phase of the operation. Next, we need to take this and multiply by the 2 by 2 matrix, -1, 1, 0, 3. So, how do you multiply two matrices together? Well, first you have to decide if the matrix multiplication is even possible. This might be it might be undefined. So the first matrix has dimensions 3 by 2. Because it has 3 rows and 2 columns. Now, the second matrix has dimensions 2 by 2. In order for matrix multiplication to be possible, the inner dimensions must be the same. So, because the inner dimensions are both 2, this matrix multiplication is possible. The outer dimensions tell you the dimensions of the product, the dimensions of the answer. So, the answer will be a matrix of the form 3 by 2. It'll be a 3 by 2 matrix. So, your next step should be to set up a very large 3 by 2 matrix, like this. Right here is a very large 3 by 2 matrix. Alright, it just has to be big enough to do all the work we're going to do, which is fairly substantial. Okay, now what do? We are going to grab the rows from the first matrix, and we will grab the columns from the second matrix. Now, this part is pretty straightforward. Row 1 goes across row 1. So I'm talking about 0, 11, 0, 11. Even though rows are horizontal, I have to write them vertically for multiplication purposes. Row 2 goes across row 2. So I will have -11, 2. -11, 2. Row 3 goes across row 3. So 3, 6, 3, 6. Now we will do the columns. Column 1 will go down column 1. So we will have -1, 1. And column 2 will go down column 2. So we will have 0, 3. Next, we need to multiply each of these pairs. So let's see. So we'll multiply and we'll get 0 and 11 and so on. Alright, I'm going to try not to make any careless mistakes, but it is difficult because this is what you call tedious. It's not hard, but it's sort of mind-numbing. And that's when mistakes happen. You take a little micro nap in the middle of a problem. It's not a good idea, but sometimes it just happens. All right, hopefully I did not make any careless mistakes. Finally, we add up the green numbers. So we will get 11 and 33 and 13 and 6, 3, and 18. But you can't leave it like this. You have to show that the final answer is just a 3 by 2 matrix, and here it is. You need to write all these little answers separately in their own matrix, and that's the final answer. For number 17, there are no parentheses, so I'm just going to use the order of operations, and multiplication comes before addition. So I'm going to start by multiplying these two matrices together, and then I will add at the end. It's a good idea to check first to see that the matrix multiplication is possible. And the first matrix has the dimensions 3 by 2. All right, the second matrix is a 2 by 2 matrix. For matrix multiplication to be defined, the inner dimensions have to be the same. So luckily, these are the same. The outer dimensions tell you the dimensions of the product. Okay, so that means when I multiply these two matrices together, I'm going to get a 3 by 2 matrix. So your next step should be to create a rather large 3 by 2 matrix. Okay, so let me think. I'm trying to estimate how large these need to be. All right, hopefully that'll be big enough. Sometimes I don't know until later. Okay, so what you do is you steal the rows from the first matrix and you steal the columns from the second matrix. So the first row goes across the first row. So I will have 2, 4, 2, 4. The second row goes across the second row. -5, 1, -5, 1. The third row goes across the third row. -4, -3. -4, -3. Now it's time for the columns. The first column goes down the first column. The second column goes down the second column. Now it's time to multiply each of these pairs. So you can see why we needed all of this space. All right, I'm not talking very much because I'm trying to concentrate. I'm trying to avoid making a careless mistake. It's very easy to do. You do this many small calculations. All right, hopefully I did not make any mistakes. Finally, we add the green numbers. So this will be 22 and 8 and negative 22 13 negative 29 and negative 1. All right, so that gives us the following 3 by 2 matrix right here. So remember, I multiplied these two matrices together, but I still have to add this other matrix. So now I need to take this matrix that I just got, the product of the first two matrices, and I need to add it to this matrix. All right, and addition works just like you would think. We're just going to add the corresponding entries, the corresponding elements. So we're going to get 24 because of the 22 plus the 2 and the 8. All right, negative 22 and negative 2 make negative 24. 13 and 5 is 18. Negative 29 and 5 is negative 24. And negative 1 and 5 is positive 4. So this should be the final answer for problem number 17. So problem number 18, inside of the parentheses here, we have a product of two matrices. So we need to do that first. But first we need to decide if the matrix multiplication is even possible. The first matrix has the dimensions of 2 by 4. The second matrix has dimensions 4 by 2. For matrix multiplication to be possible, the inner dimensions have to be the same, which they are. So far so good. The outer dimensions tell you the dimensions of your product, the answer. So when we multiply these two matrices together, we are going to get a 2 by 2 matrix. So in response to that, the first thing we should do is build a rather large 2 by 2 matrix. Okay, it should be fairly big. All right, now what we do is we take the rows from the first matrix and we take the columns from the second matrix. Let's do the rows first. Row 1 goes across row 1. So I'm going to have 2, 2, negative 3, negative 5. Row 2 goes across row 2. Now we will take the columns from the second matrix. So column 1 will go down column 1. So that gives us negative 3, 3, negative 5, negative 5. And column 2 goes down column 2. Next, we need to multiply each of these pairs. All right, I'll do the rest of these off camera. This is getting too tedious. So these are the numbers that we will get after we multiply all of the pairs. Next, we need to add all of the green numbers together, and that will give us the final answer as far as this product goes. So for example, well, -6 and +6 cancel each other out. And that leaves 40. All right, so this makes a total of 40. All right, I'm going to add the rest of these. Well, you know what? These are so simple. All right, I won't go off camera. So let's see. -2 and 12 make 10. 10 and -10 make 0. So this should be 8. And this makes 8. And this makes 8. It's a lot of 8s. All right, so when we multiply these two matrices together, we got this little 2 by 2 matrix shown here. But we still need to multiply by -2. And this is called a scalar multiple. All right, where when you have a number that you're multiplying by a matrix, the number is called a scalar. But anyway, all we do is we multiply each one of these entries, each element, by -2. So of course, that is going to give us the final answer of -80, -16, -16, -16. So that is how you do number 18. For number 19, we must follow the order of operations. Multiplication comes before addition. So first we have to multiply these two matrices. Even though there are no parentheses, we still have to do this first. So in order to see if this multiplication is even possible, we need to check the dimensions of each matrix. The first matrix is a 2 by 3 matrix. The second matrix is a 3 by 2 matrix. For matrix multiplication to be possible, the inner dimensions have to be the same. Since these are the same, that means this multiplication will be possible. The outer dimensions tell you the dimensions of your product, the answer you get after the multiplication. So that means the product is going to be a 2 by 2 matrix. So what you need to do is make yourself a rather large 2 by 2 matrix. And then you steal the rows from the first matrix, and you steal the columns from the second matrix. Let's start with the rows. Row 1 goes across row 1. So -2, 3, -4. Row 2 goes across row 2. Now we do the columns. column 1 goes down column 1. And column 2 goes down column 2. So now it's time to multiply each of these pairs. So for example, -2 times 5 is -10. 3 times -1 is -3, etc. Next, we add up all of these green numbers. So let's see, this is going to be -25. And this is going to be, or that's 24, 28, 37. -30. And 12. All right, I'm going to need a little bit more room. Let me slide over here. So remember, we multiply these two together, but we still have to add with the original matrix. So I'm going to do that over here. So we have to take the matrix 1, 4, -5, 6, and now we're going to add it to the product that we just found. -25, 37, -30, and 12. All right, and if we add these together, and again we're just adding the corresponding elements, this is going to give us -24, and then 4 and 37, that's going to be 41. -5 and -30 is -35. And 6 and 12 is 18. So this should be the final answer for number 19. Okay, this will be the last problem. So we have multiplication combined with addition, but unlike the last problem, this time we have parentheses around the addition. That tells us that we have to do the addition first. And you add by just adding the corresponding elements. For example, -3 and 2 is going to make -1. And then -6 and 6 is 0. -1 and -6 is -7. 0 and 2 is 2. 5 and 3 is 8. 2 and -5 is -3. All right, so now we have this matrix right here. So now I brought down the first matrix and it's time to multiply these. We really should check one more time and make sure that this matrix multiplication is possible by looking at the dimensions. The dimensions of the first matrix are 2 by 3 because this has 2 rows and 3 columns. The dimensions of the second matrix are 3 by 2. In order for matrix multiplication to be possible, the inner dimensions have to be the same. These are the same, so this will be possible. The outer dimensions tell you the dimensions of your answer. So after we multiply these, the product will be a 2 by 2 matrix. So the next step is to set up a rather large 2 by 2 matrix where we can do the work. So I'm going to make a pretty big 2 by 2 matrix right now. Okay, and what you do is you take the rows from the first matrix and you take the columns from the second matrix. All right, let's do the rows first. Row, whoops, I wanted to use a different color. All right, row 1 goes across row 1. So I'm going to put my -1, my -4, and my 0 in the first row. Row 2 goes across row 2. -1, 1, -5. Now it's time for the columns. Column 1 goes down column 1. Column 2 goes down column 2. Now it's time to multiply. And finally, you add up the green numbers. All right, so the final answer we just need to write separately as 29, -8, -46, and 17.